Last year, my beloved aunt passed away from a diagnosis of a brain tumor. She was a cheerful person, always brimming with fascinating stories. But as the time passed, those captivating narratives turned into a jumble of random sentences that perplex us all. Not even she can recover. Within 2 months, she changed. The brain tumor changed her. The harsh reality really hit me. The brain tumor are truly terrifying. Even the International Agency for Research on Cancer, or IARC, reports a staggering 250,000 deaths caused by brain tumor annually. And did you know that only about 17 out of every 100 people with cancer's brain tumor survive for only 5 years or more? Immediate treatment is crucial, as the risk of mortality increases exponentially when it left untreated. In my country, Indonesia, analyzing a single case of a brain tumor often requires not only one doctor. It could be 2, 3, 4, 5, or even 6. From oncology to neurosurgery. However, it takes a lot of effort, money, time, so this approach has a limitation. Besides, the MRI image processing with a confined scope and the brain homogeneous cell structure poses a 70% chance of failure. Here's where technology steps in to make a difference. Machine learning algorithms have shown promise in the detection of brain tumor computationally, but unfortunately, their limited scope make it difficult to process a big data. This is where the deep learning comes into play. Its flexibility in a brain tumor detection with a substantial amount of input data make it work effectively. And that's where our innovation, NeuroDetect, emerges as a potential solution. We are focusing on algorithm development by comparing VGG19, CNN, deep learning, and KNN methods based on MRI image to get higher result of validity.
Can our algorithm detect brain tumor accurately, effectively, and efficiently that will integrate with mobile apps?
Therefore, with pride, I am Chili.
And I'm Naufal.
From One Mountain, proudly present
NeuroDetect early detection of brain tumor stage
based on MRI image with KNN and deep learning algorithms integrated with the mobile app.
This research was conducted for 6 months in Malang City and Brawijaya University. Secondary data was obtained through literature studies. Primary data is obtained from MRI image of brain tumor patients in the Google dataset and Kaggle database, as much as 800 dataset datas, as well as direct collection from X Hospital in Malang City. 800 data are divided into 80% for data training and 20% as validation data. The BATS algorithm is used for developing NeuroDetect. With the flow, user interface, UI, and user flow chart, and beta testing it on MRI image from local hospital. The dataset will be divided into several types according to the research variable multi-one pituitary minimum IQ. This dataset will then be processed through deep learning and QNN CNL algorithm. Visual process with code function starting from data collection, labeling image, resizing, and augmentation are performed in the image data preprocessing stage. Next, training and testing the data using several algorithms. The first test was on VGG19. The accuracy of the VGG19 model was unstable and became more nonlinear with more repetition. The validation AUC remained constant at 98%. With 2 evaluation classes, the modified VGG19 model achieved F1 of 92% and recall of 94%, showing improvement with increasing number of training image and hyperparameter. The second training on the CNN model saw shortcoming in the nonlinearity part, which is evident in the recall part graph, which is almost constant as iteration increase. The steep gap between the training and testing learning curve reflect the difference in model correlation. The third training and validation of the combined deep learning model integrated with the QNN algorithm result in 98% accuracy, 91% F1 score, and 91% recall. Although the metric and ensemble are lower than other models, the loss rate is only 2%, making it the main reference in this study.
The main model is deep learning integrated with k-nearest neighbor algorithm, implemented using Python and hard models. Of the total data, 18% is used for training, with a breakdown of 10% for validation and 10% for testing. The training parameters include a learning rate of 0.001 for 18 epochs and a batch size of 16 with a cross-entropy category. An integrated deep learning model was tested using an Android application to detect the brain's tumors. The selection of Android device was chosen due to ease of use, lightweight, and compatibility with various Android versions.